Alright guys, so let's take a step back and remind ourselves how we go about solving a right triangle. So if we remember, got ourselves a right triangle, and it's got our reference angle, let's say 42 degrees, whatever it may be. It's going to be similar to any other right triangle with a 42-degree angle. That means the ratios are going to be the same. So since this is my angle right here that's marked, it's got a number in it, I'm going to label my triangle based on that angle. So this is my hypotenuse. Doesn't matter what angle we're talking about, it's crossing the right angle. Hypotenuse, done. Then we look at what angle we're talking about. The side that it does not touch, see it's if we mark it from side to side, the side that it does not touch is our opposite side. And that leaves us with our adjacent side, or the other side that it does touch. So the reference angle touches the adjacent side and the hypotenuse. The hypotenuse is opposite of our right angle. Okay. Now after you label your triangle, then you just have to remember, some old hippie caught another hippie tripping on acid. That's your ratios. So S is for sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then finally we have tangent is opposite over adjacent. Okay, that's our three trig ratios. Again, it's just the ratios of these sides, which based on angle similarity is they're always going to be the same. No matter what the side lengths are, when you divide them, they will have the same ratio. So, if you remember, this wasn't the last day. The last day we did 30, 60, 90s and some uh, applications of it, but before that, we talked about how to just type in your calculator, set it up and solve it. And here's a more legible version of that. My writing isn't the best. So if you have a side, you just type exactly what you see. Shift, calc, equals, and wait a minute. It's going to take some time. It's got to think. And it'll spit out your answer. It's going to be a decimal. You can round to the tenths place. That'll be fine. On the other one, we have an angle. If you have an angle, you're going to have to use an inverse trig function. So on here, we got some sort of triangle, and we're looking for a side. Let's say we're looking for a side. It's going to be like that. We're looking for a side. It could be the opposite, adjacent, hypotenuse, whatever. But we're looking for a side. If we're looking for an angle, we'll have some numbers on two of the sides, and we'll have our variable inside the triangle somewhere. It could be here, it could be there. It will not be here because that's a 90-degree angle. We know that. But if we're looking for an angle, we're going to need the inverse trig functions. To get those, we do shift, and then we type whichever trig function we need based on our ratios here. You got to know this, no choice. I'd suggest at the start of every problem, just write this down. Say in your head, some old hippie caught another hippie tripping on acid. Write it down, Sohcahtoa, until it's ingrained in your brain and you know it better than your math facts. And then you type your ration, I meant ratio, of course, and hit equals. So if we know the opposite, let's just say this is 3 and that's 5, then we'd have the opposite and the hypotenuse. So we would use sine, we'd hit shift sine, and we type in 3 over 5. I'm going to do some examples with you in a minute on the sheet for today. So we're just going to take a step back and just look at some triangles. Before I actually solve any of these, I'm just going to label my triangles. First thing I'm going to do, I'm going to label all my hypotenuses. Sure. So there's my right angle, there's my hypotenuse. Right angle, hypotenuse. Right angle, hypotenuse. Right angle, hypotenuse. The hypotenuse doesn't care what angle you're referencing. It doesn't. It doesn't matter. We got our right angle, across from that is our hypotenuse. The right angle does not touch the side, that is your hypotenuse. Okay, Now let's talk about the opposite and the adjacent. For that, we need to decide which angle we're referencing. You see how this has absolutely nothing in it, and this has a theta in it? That means this is the side we're referencing. So I'm going to go ahead and mark that with an arc. That way I can see what it's touching. Oh, it's touching this, so I know that's the adjacent, but it's not touching this one, so I know that's the opposite. Opposite, adjacent. And I had already had my hypotenuse, so that's why I knew this was the adjacent and not this one over here. Again, reference angle, opposite, adjacent. Reference angle, opposite, adjacent. And reference angle, opposite, and adjacent. Now I'm only going to type one of these in the calculator for you, but I will set them all up. What are we looking for? Are we looking for a side? Side? No, I've got numbers on two sides. I'm not looking for this side. It doesn't have an X there. I'm looking for an angle. Remember, this is the theta symbol. It's a Greek letter. It's our typical symbol for an unknown variable. So I'm going to decide what do I know and what am I using. Since we're looking for angles, we should know two sides. So I have an adjacent and a hypotenuse. I completely forgot. So I'm at the top of my page. I'm going to write some old hippie caught another hippie tripping on acid. Perhaps you should do it for every single problem until it's memorized, and keep doing it after it's memorized. Now we have the adjacent is 12. The hypotenuse is 13. The opposite, we don't have the slightest idea. So we're not going to use the opposite because we don't know the opposite. So that crosses out sine and tangent. Do we know the adjacent and the hypotenuse? We do. So let's write down what our ratio should be. It's got to be a cosine. So cosine. What's my angle? My angle is theta. We don't know it, so we put the symbol that it says, theta. And what is it equal to? Cosine is adjacent over hypotenuse. That's 12 over 13. Now to solve this, we are looking for an angle. So we're going to hit shift and then either sine, cosine, or tangent. In this case, cosine. Type in the ratio and hit equals. So in my calculator, I'm going to type cosine inverse. So shift cosine. And it's going to open up a parenthesis, and I'm going to type in 12 over 13. You can close parenthesis or leave it open. It doesn't matter for this case. And hit equals. I'm going to close it just for completeness. So here's my calculator. First, I'm going to check and see I should be in degree mode if it's, yeah, I'm going to check. Sine 30 should be a half. I'm in degree mode, cool. So that had nothing to do with the problem, I was just making sure I was in the right mode. I can't really read that, but it's just probably a D. If it's an R, that means you're in radio mode and you need to change it. Oh, I can actually see it up here, sorry. So yes, we're in degree mode, good. Back to the problem at hand, cosine inverse. So shift cosine. And you see cosine inverse pops up. 12 over 13. I need a fraction. 12 over 13. I hit equals. 22.6. The end. If we look at number 2, I've got the opposite, I've got the adjacent. That means I'm going to be using tangent. So tangent of theta equals opposite over adjacent. And just like over here, we'd hit shift, and this time we'd hit tangent. 4 over 13 equals. Over here, let's see what we've got. We know the hypotenuse, we know the adjacent, so that's another cosine. So cosine of my angle, which is theta, equals adjacent over hypotenuse. Shift Shift, cosine, type in your fraction, hit equals. Let's look at this last one here. This time we know the opposite and the adjacent. Oh, that's another tangent. So tangent of my angle, which happens to be theta, is opposite over adjacent. It doesn't matter that it's a decimal, just type it in. It'll be perfectly fine. So shift, tangent, this fraction equals. Now notice the difference here. Here, we didn't know our angles, but we knew two sides. Over here, we know our angles, but we only know one side and the other side's an x. That means we're looking for a side. So again, let's label our triangles. I'm going to mark all my reference angles. Whatever angle has a number in it is your reference angle. I'm going to label my hypotenuse based purely on the right angle. The reference angle does not matter in the least. I'm going to label my opposites next. I'm just going to look at my reference angle and mark the one that's not touching. And finally, I'm going to label my adjacents. It's the other one. Again, I'll fully solve this one for you and just show you the setup of the others. So now, since we're looking for a side, there's only one possible answer, so we can actually just type it in like we see it, just like we're solving a linear equation. So first thing to decide is which trig function. I've got my angle. I know my adjacent side, so I'm gonna, oh no, I don't know. Some old hippie caught another hippie tripping on acid. That's an A. Sure. So we got the adjacent, so sine's out. We're looking for the hypotenuse. We don't know the opposite. We don't care about the opposite. No one loves the opposite. The opposite's gone. Nothing. So cosine. Adjacent, hypotenuse. Cosine of my angle is equal to adjacent over hypotenuse. 11 over x. So I'm going to take that and type it in exactly. Cosine of my angle, which is 37, now this one you do need to close the parentheses. It does make a huge difference because we're doing something afterwards. Alpha calc to get the equal sign. 11 over x. 11 over alpha close parenthesis to get x. Don't hit equals, hit shift, calc, equals. And it thinks, and it thinks, and it thinks, and it thinks until it stops thinking. Be patient. Oh, there we go. 13.8. Call it a day. It's 13.77. We're rounding to the tenths place, so the next number's bigger than 5. That's going up to an 8. 13.8. X equals 13.8. Done. That's all there is to it. That's it. So let's set these up. So my angle's 32 degrees. I know I'm looking for my opposite, and I know my adjacent. Tangent's got to be the way to go. Tangent of my angle is equal to my opposite over my adjacent. Type it in, see what it tells you. This time, opposite and adjacent. Another tangent. Tangent, of my angle equals opposite over adjacent. Alright, so let's look at number 12. So if we look at it, it is a 60-degree angle. You can use your special rights to do this one. So if we look, we know the hypotenuse, and the 60 is over here. We don't care about that one. We need to get to the one across from the 30. That's 30, so crossing that's half of that. So our answer should be 5.5. We divide 11 by 2. However, we can still get the result the same exact way. So let's set it up. We know the hypotenuse. We're looking for the adjacent. Sorry. So cosine, adjacent hypotenuse, of x over 11. I forgot the 60. Sorry, guys. Let me just squeeze that in there. Cosine of 60. There we go. Equals x over 11. So yeah, if you remember, we're going from the hypotenuse to the one across from 30. It's a 1, 2, square root of 3 triangle. So 11 divided by 2, it should be 5.5. Let's see, cosine 60 equals, now I forgot x over 11. X over 11, yeah, that should be it. Shift, calc, equals. Oh, yeah, there it is, 5.5. Yay. Alright, and that is literally all there is to it. So if you look on here, in addition to this video, I gave you an example of how to solve it. But come on, guys, you gotta practice. That's the only way you're gonna do this. You should have been able to do this on yesterday's quiz, but you know what? It is what it is. Get some extra paper and do the thing. Label your triangles. Write out your setup. And if you're looking for an angle, show the inverse. If you're not, well, then just give me the answer. It's just practice. Practice, practice, practice. Alright, guys, so let's just call it a day there. And if you have any questions, message me on Google Classroom. See ya.